MS Ramaya University of Applied Sciences.
Current voltage characteristics of a solar cell. Hello students, let us discuss the study of voltage current characteristics of a solar cell and calculation of fill factor of the solar cell. First, let me introduce the working principle of a solar cell. There are two different kinds of cells which are sensitive to the light: photoconductive cells and photovoltaic cells. Solar cell is a photovoltaic cell which converts light energy into electrical energy. It consists of a diode made up of a semiconductor. The operation of a photovoltaic cell requires three basic attributes: the absorption of light, generating either electron-hole pairs, the separation of charge carriers of opposite types, and the separate extraction of those carriers to an external circuit. When the energy of the incident photon is larger than the band gap, the photon is absorbed and an electron-hole pair is formed. These electron-hole pairs are separated by a strong barrier field existing in the depletion region. The accumulation of electrons and holes on the two sides of the junction gives rise to an open circuit voltage VOC, which is a function of illumination. By varying the resistive load, we can plot the current voltage characteristics of a solar cell. The important electrical parameters of solar cell are open circuit voltage, which is the maximum voltage obtainable at the load under open circuit conditions; short circuit current, which is the maximum current through the load under short circuit conditions. Fill factor is the ratio of maximum power to the product of open circuit voltage and short circuit current. From the voltage current graph, we can find the knee point and can determine the maximum power point where cell delivers maximum electrical power. By measuring open circuit voltage, short circuit current and maximum power point, we can calculate fill factor of the solar cell, which is a measure of quality of solar cell. Hi students, in this experiment we study the VI characteristics of a solar cell and determine its fill factor and efficiency. To conduct this experiment, the apparatus that we use are the light source, the solar cell, and solar cell characteristic apparatus which has internally connected millivoltmeter, milliammeter, potentiometer where you can vary the resistances, the two terminals across which the solar cell can be connected. Let us start the experiment. First, switch on the light source and the solar cell characteristic apparatus. Connect the solar cell with its P side connected to positive terminal and N side to the negative terminal. Keep the solar cell at a fixed distance from the light source. Care should be taken to see that the distance of the solar cell from the light source is kept constant throughout the experiment. First, let us find out the open circuit voltage of the solar cell. For that, remove this wire connection. Now the circuit is open. Record the value shown in the millivoltmeter. 0.438 is the open circuit voltage VOC of the solar cell. Next, let us find out the short circuit current, that is a maximum current that can be obtained from the solar cell. For that, let us connect the wire. Turn the potentiometer knob to the SC position. Record the value shown in milliammeter. 7.75 milliamps is the short circuit current of the solar cell. To study the VI characteristics of the solar cell, turn the knob to 10 ohm position. Note down the value shown in millivolt meter and also in the milliamp meter. Turn the knob to 22 ohm position. Record the values shown in the millivolt meter and the milliamp meter. Repeat this for all the values 47 ohm, 56 ohm, 68 ohm, 82 ohm, 100 ohm, 150 ohm, 180 ohm and 1 kilo ohm. At all these trials, record the values of the current as well as the voltage. From the recorded values of voltage and current, plot the graph by taking voltage along the y-axis and current along the x-axis, which will give the VI characteristics of the solar cell. From the graph, determine the maximum power that can be obtained from the solar cell. Using the value of maximum power, efficiency as well as fill factor of the solar cell can be determined.
At MSR UAS, we spark your imagination unlike any other.